welcome to Desk Ladyada.
Hey everybody, and welcome to the Desk of Ladyada. It's me, Ladyada, and welcome to my desk. With me is Mr. Ladyada on camera control.
Word to your mother.
Ooh, it's right. It's Mother's Day, so for those who are thinking about it, maybe call your mom. If you don't want to call your mom, believe me, I understand. You don't have to, but if you want to, I don't know. It's up to you. You decide. But once you're done with that, come on by and we can hang out at my desk and look at electronics.
Yeah, we got a lot of stuff going on this week. You can see some progress that we have. We're posting across all the social media channels pretty much 24/7. But Sunday is when we kind of collect things together to figure out what, when, and if we're going to release something. So what's on your desk this week?
Yeah, let's look at my overhead because I set up a couple of things. I was actually working on some electronics this week. So first up, I think I showed these. This is a Zippy navigation.
Yeah, that little video is going to come out probably tomorrow.
But that's okay.
You can do a live demo.
I can do
tonight.
a live demo. Hold on, let me get my. Hello.
Might want to move the camera physically a little bit.
Sorry, I forget. There you go. Okay, now it's zoomed in. Okay, so this is a click scroll wheel. It's reminiscent of the iPod. It's not the same one as in the iPod. It's made by Zippy. It used to be made by I think eSwitch or something, but Zippy makes, which they make a lot of mechanical stuff. They make a version, and it's got a rotary touch wheel, a rotary click wheel in the middle, and it's got 4 buttons, north, west, south, east, and then one in the center. Got it hooked up here to a Feather M4, and it's just reading the rotary encoder, and as you can see, it's spinning in NeoPixel to match. You can even maybe hear a little bit of the clicking. And then there's, if I press the up or left or down or right buttons, and then the center turns the whole thing on. So there's a little demo showing this breakout because the board is the sensor itself has a totally ridiculous pinout, and so this is just a little adapter that makes it breadboard friendly. So not a big deal, but I wanted to start playing with this a little bit more, and to test the footprint. I was like, I might as well make a breakout, so did that. So that's one thing. I also put together this prototype, which I was distracted by Trinkies. And, I was also like, TFTs got really expensive, and they're still really expensive, but I wanted to finish it off. This is a 1.69-inch IPS TFT display, and you can tell it's a rounded rectangle, so it actually has the pixel cut off, like it's missing pixels. It doesn't have it's not like a different mapping, it's just there's just a cutout, basically.
Do you think that's because the actual iconography is all rounded corners now, or is there... Why is there?
It's just for smartwatches. This is so you can fit it into an enclosure.
And so instead of having to work around that with a physical design,
where you'd have to make it bigger,
you have to make it a little bigger and then make it look like rounded corners. Now the screen itself does rounded corners, so
and so you don't have to worry about it just means your case can be a little smaller.
Gotcha.
Yeah. So this is a few folks remember we were experimenting with we really like Quick and STEMI QT, which is plugging in I2C. Here's the rotary encoders that we just put in the shop. I2C stuff connecting with 4-pin wires. Grove does this, STEMI does this, but for SPI and displays, it was something that we were starting to get a little annoyed by. It was every display had the hardware SPI and then a chip select pin, a data command pin, a reset pin. If there's an SD card pin, there's a chip select for the SD card. If there's a touch screen, there's another chip select. And so it's not like just I2C where you're 4 pins and done. You actually need a lot of pins. And we saw that DF Robot actually came up with a standard that they called, I think it's just generic display interface. I don't really have a name for it. And I was like, oh, that's a good idea. And I like to stick with other people's standards so that, I don't like to invent new standards. It's not my favorite hobby. So on this display, we have a little flip top for this flex cables. Flex cable has 18 pins, and I always like the bottom contact type because I feel like it's easier to insert. And then if you plug this in, it'll show. I don't think we got to show that we actually have a logo that you designed, and you can see it's being inverted, but that's the iSpy logo. So SPI Flex for display connectivity. Putting on a 20-cent connector on the back just means, like, look at how easy it is to connect a TFT display. A lot like this, there's such a pain to wire, but really the pinouts are very standardized. So so this actually got done this weekend, so this is ready to order, and I got the pinout right this time, so good for me. That's the SD card being tested. What else? Some keyboard stuff showed up. So my break apart ortho key PCB. So you can actually see, this has the routed cutouts. I haven't tried breaking this apart yet. I'm a little nervous to do it. I have a couple of these PCBs, but not a lot. But, in between, there's a little bit of a couple very small holes and the two traces that connect each one to each other. So I'm hoping that, you'll be able to easily break this apart and make custom ortholinear keypads, and then, you plug in your Cherry MX keys into the KL sockets, and there's a Neo pixel on the bottom. So check out the previous videos for this, 'cause it's got rows and columns, and it's diode matrixed in between.
Okay, for that connector on iSpy,
Yeah.
are you going to do a great search about it, or like what
I've
is this?
kind of covered FPCs already, so I don't think I'm going to do a special one just for that.
What is that connector called?
It's just a sort of generic 18-pin FPC connector. If you look, one of our first great searches was about FPC connectors, and just instead of 40-pin or whatever, I pick 18. And that's
Okay.
it. I got the PCBs for the macro pad, RP2040 designs. This is going to have like an OLED, rotary encoder, and 3x4 keys. So we just got these on Friday, so I haven't had a chance to put them together yet. But I think I will do that soon.
On our blog and on the social medias, we posted up our take on the Arduino Pro Micro size boards, but we're doing RP2040 for the Keeb community, so we're just calling it like...
This is Keeb, but this is all in one. This is like a macro.
So there's a lot of keyboard stuff going on. So that'll be something to check out.
Why? Because mechanical stuff is in stock. That's why people are like, why are you suddenly doing all this mechanical stuff? Because I can get them. There's no parts shortage.
Some are keyboards.
There's no shortage. There's some shortage of chips, but as long as I can get any chip, in this case the RP2040, I can make a macro pad because every other component is a common jelly bean, and I have enough stock. Speaking of the Keeb, so if you want to go to the computer and we can show off the keyboard design that I did yesterday night. So after a while, like I just couldn't watch SNL anymore. Like I didn't. It wasn't that funny. So I came upstairs and let Phil suffer through it, and I designed a circuit board instead. So. I think everyone's loss is your game.
So the segment that you missed, and you can watch it online, is the Pete Davidson character Chad. He was stranded on Mars. There was an issue of oxygen.
Yeah.
And Elon kind of plays himself with that.
See, I think Elon can play himself. I just don't.
Yeah.
I just don't think he should play anybody else.
So I think that was one of the funny ones.
Okay, I'll check it out.
Yeah, you can.
It's
on
YouTube.
Online. And I did think the. Anytime people dress up in any type of Mario characters, it doesn't even need to be funny, but it looks funny.
It does look funny. And sometimes physical humor is all you need.
Yeah. Okay.
Okay, so doing keyboard stuff, and people really like using Adafruit boards in keyboards, and we've designed Itsy Bitsies. And I noticed that Itsy Bitsy, the pinout never cut on with keyboards, even though I thought it was like kind of cool because it had more GPIO and it had a NeoPixel driver pin and had V-High available, but it turns out people really like the Pro Micro pinout. And so I thought, okay, well, since so many people are using CircuitPython with the RP2040 make keyboards, I should make a CircuitPython happy RP2040 board. It's basically like the Itsy Bitsy, but it's got the pinout of a Pro Micro. And thankfully, it was actually I always find it kind of amazing when the pins just sort of like magically fall into place. Like this is a very this really was a very it was like a lot of flow. Like I felt like really like it was happening because pins like 0 through 9 on the Pro Micro are down here, and those match up 0 through 9 here. Like they're like one in a row, and even the alternative function. So the TX and RX pins are like it's TX, RX, SDA, and SCL, and it's exactly the same as the Pro Micro. So it's like even if you're using the UR or I2C peripherals, it's like a drop-in replacement, which I thought is sweet. One thing I did change, and this is the big thing I changed with the design, is the Pro Micro doesn't have a pin at the top, which I'm not sure exactly why, but there's actually like one pin gap missing. And I added it back and I made it connect to D plus and D minus because I noticed a lot of people, it's like they want to make a keyboard, but they may not necessarily want the USB-C there. They may want it to be connect to like another keyboard or, you know, I don't know, like they want it to go through an enclosure and then there's like a panel mount. And also the old crows always asking, like, can you put the data, you know, D plus, D minus pins? And I know in Pedro also I see them, they make projects, sometimes they end up extending the USB out for some reason. And so I thought, you know, if we have these two slots, let's add the two data pins. And then I also put a jumper here that lets you short out. There's a fuse and a protection diode. And those are good, but like if you want higher current, I wanted to give people an option. So this lets you short them, which basically just means like you have to be a little bit more careful, but it's not a big deal. And then it's got the 8 megabytes of flash memory over here, the RP2040 chip. It's got a NeoPixel here. There's a power LED, but it's interesting. The Pro Micro doesn't have a D13 LED that I can notice. So for the boot button over here, I put that diode in that lets you use the boot button as a user button. So that's kind of nice. And then SparkFun made a Pro Micro of the RP2040, and they put a STEMMA QT quick connector on the end. And I was like, that's a really good idea. So I grabbed that idea from them. So this is a little bit, and then it castellated pads like the Elite C, which is a really common keyboard microcontroller. So I picked a little bit of everything, and I was like, okay, well, I don't really know what I'm doing, but I think this could be a good design for people. And it fits all on a double-sided board, so it should be pretty inexpensive. And there's a good ground plane, and there's like lots of GPIO. So I think, you know, most keyboard designs have settled on like, you know, you should be able to do them with the number of pins available on a Pro Micro. So I think this is good to go.
Yeah, and we do have a person in the chat that I agree with. I've seen this a lot over the years, is the cheap clones of the Pro Micros, the USB ports just rip right off.
Yeah, I've always preferred, I never liked having surface mount only USB, you know, USB, micro USB. But for these USB-Cs, you see that there's these through holes. You cannot rip them off. Believe me, you will rip off the PCB before, like, it will delaminate before you pull off the USB. It is so strong. I have Mr. Ladyada test that for me.
Yep.
He does that.
Okay, what else?
Okay, so that's this keyboard. It's called the KB2040, for lack of a better name. So that's that. And it should just come out. It's exactly like the Itsy Bitsy or the Cutie Pie. It's like the exact same design. Just like with a lot more ground pins, and then like there's, you know, a raw pin over here. Okay, great. So that's that, and then okay, and then lastly, let's go back to the overhead for the last thing before we.
Were you gonna show the?
Oh yeah. So right. So and also last week we talked about this pinout generator, and we actually got some pinout generated this week. So. You know, Phil B worked on this a lot. Kattni worked on this. So the colors that are picked there, these are actually not just any colors. These are picked from a specific palette of colors that are readable no matter what kind of color blindness you may have. Like if you have trionic or bionic, I don't know, there's like 3 or 4 different kinds. But these are like really safe colors. So they're very beautiful colors, but they're also really accessible, which is great. So we started with the RP2040, and then I've also got here I'm working on the ESP32S2. So again, for every chip, there's always a little detail, something I have to kind of noodle around with to make it work. So with the ESP32, unlike the RP2040, one of the things about it is not every pin has every function. So you see, like these pins have this is called the power domain. So it's like whether you can use an RTC mode or not, like in low power mode. So the nice thing about the RP2040 is every pin has a PWM output, and every pin has an I2C, and every pin has a UART, every pin has SPI mux. Like they just completely cross-barred the whole thing. But with the ESP32, it's like there's some pins that are special high-speed SPI. There's some pins that are touch. there's some pins that are debug or have, crystal output. So there's going to be these gaps in between. So we're still working on that. But you can see like here, these are DAC pins, but they don't have, the high-speed SPI or something. So, but it looks good so far. Like I'm liking the look. So we're going to do some ESP32 S2, and these are the pins that are like floating. So like these debug pins are actually like right here. You can kind of barely see them. And then this NeoPixel pin is actually for the NeoPixel over here. So we're going to have to like point them out and be like, this is a pin for an internal connection. It's not an external connection. But so far, the automatic generator is working really well. So the nice thing is like this is all fully automatically generated from the fritzing file and the CircuitPython pin alias name file, which is how I determine like what we call the pin. It's like what is the NeoPixel pin called? I know it's pin 45, but what's the human friendly name? It's NeoPixel. So there's a lot of pins that have friendly names like MISO and S-Clock and VDiv and A2. So all those friendly names we're parsing out.
Yeah.
So that's coming. That's what we're going to be more. We're going to keep working on that. It's like happening.
And there's folks that are colorblind in the chats, and they're like, "Thanks for doing this."
Yeah.
We'll always do the best job we can for absolutely everyone. One thing, and I want to thank the community, is people assume the best in us. Sometimes we don't get to everything right away, or we'll be updating something. But we always go out of our way to help people. We don't go out of our way to exclude anyone. So thanks for cutting us slack. Because like once in a while, like we'll have a graphic or a chart or something. We're like, oh, let's make sure it's good for everyone possible. But sometimes we just need to update stuff if we didn't get to it, or even if we missed it. Okay.
Yes.
So do you want to go over to Is It Great Search Time?
No, not quite yet.
All right. Because I see Digi-key and I'm just like, well,
I know, but I was actually looked something and I realized it's not there. So let's just go to the overhead real fast. We're really almost done. We're already.
That's fine.
We're wrapping
It's your
up.
show. Do whatever you want.
Well, I want to make sure that we get to everything. So with the Seesaw boards, which I'm loving, and we just got the rotary encoder out. This is like a 3-year-old project, and I finally finished it. So the rotary encoder, reads the rotary encoder and gives you the values for I2C, and there's a NeoPixel. Wonderful. We just put them in the shop. We're going to be making more. The chip that's used on this is the SAMD09, which, until a few months ago was extremely plentiful, like water, raining from the skies. You could get SAMD09s, these very inexpensive Cortex M0 chips. I really loved them because they were very fast. They had a lot of RAM, a lot of flash, and were very inexpensive. I was getting them for a great price. I got a great price from Microchip for them. But then... you can't really get them anymore. So I have some stock, right? I have, I'm not like the car companies. I buy stuff and I broker it ahead of time, and so we have some coming and we have stock. But I have a huge pile of all these Seesaw type boards, not just the rotary encoder, but I want to make one with this encoder, and I want to make one with a joystick, and I want to make one, I have all these little Y2C to button thing, again, mechanical stuff. And the chip itself, I'm a little hesitant to design. If I'm going to be designing the PCB, I might as well pick a chip that I know I'm going to be able to get a lot of. And we chatted about this. I looked at the MS51, which is the cheapest microcontroller on Digi-key. You search for microcontroller with 8 to 16K of flash. Nothing is cheaper than this. It's 30 cents. It's dirt cheap, and it has some nice benefits. This is also a chip that Primera uses in their I2C. They have a Seesaw thing, which I don't know what they call it inside, but it's not open source, I think, but it's it's an MS51 if you look, and then they write code on it to do I2C stuff. One of the things that's nice about this chip, other than the fact that it's 30 cents, which is amazing, and I'm sure you can get even cheaper if you go direct or you have a broker, is that it can do 3 or 5 volt logic, and it's 5 volt safe. So, one of the things that I have to do on all these boards is because people are using these with an Uno or they're using with a Mega, they're powering with 5 volt and they're using 5 volt logic. So I have to have a logic shifter and regulator. And it would be kind of nice if I could skip those. I have plenty of regulators and shifter chips, but it is an extra 30 cents-ish, 20, 30 cents. And it's another thing that I won't be able to get. So I got this dev kit and I was like, yay, I'm going to get this. And then, of course, all the MS-51s disappeared from the face of the earth. And the lead time is 2 years. which is
What's Seesaw for the folks who don't know what Seesaw is?
oh, Seesaw is the firmware that is on this little chip that reads the rotary encoder. It's a microcontroller. It reads the rotary encoder, and then it has an I2C interface as a peripheral, so you can read what the value is. So it's a like I2C to anything converter. So it's a firmware, so that because like an I2C analog digital converter is like it's like $1. It's like it's cheaper to get a microcontroller, program it with your custom firmware, and for stuff like this where it's you don't need heavy duty specifications, it's good enough. The problem is that the SAM-D09, like I said, it's evaporated. So I looked around and I was like, I spent like an evening and I was like, what's a chip that I'll be able to get that's inexpensive and 5 volts, friendly. And so far, I think the thing I found was the AT-Tiny 817 and 816, in that series. So it looks like there's going to be a lot coming into stock at Digi-key soon. Like I kind of did the thing where I checked the lead time. It's 3 to 5 volts. It's got I2C peripheral. It's one of the new AT-Tinys. So one thing that I thought was really neat. So the programming chip, I thought like, oh, does it use like the SPI? It actually doesn't. This is SPI, but it's not. It doesn't use this for programming the chip. The chip is actually programmed with an asynchronous serial protocol, which I thought was really smart because you don't need special hardware to do asynchronous serial. You just need one resistor and a serial port, which means that I could, even without a bootloader, you could plug in, look, maybe I can write a bootloader, but you can plug in to these pins and maybe short a jumper or two and then use the same wires connected to a UART on a microcontroller to program in the chip, like raw, like program the chip completely, even if there's no bootloader on it. Which I thought would be kind of neat in case people wanted to upgrade the firmware on these little boards, or like, if somebody finds a bug once in a while, I can fix it and send them new firmware. So I'll do a great search about how I found the 817, 816. But I think this is going to be what I'm going to use. And I think I'm just going to have to redesign the boards before I get them into production, because I do have a stash of SAM-D09s, but I don't know if they're going to last a whole year, especially if I come up with like 10 new products. Okay. All right, speaking of stuff out of stock, it's time for the Great Search.
Where in the world is that part I need? The Great Search with Digi-key.
The Great Search brought to you by Digi-key and Adafruit. Digi-key, thank you so much. More so than ever, the Great Search is now becoming the most popular segment across all of our shows. Because before, back in the time of plenty, it's like, oh, why do you need to search for anything? You can just find chips everywhere. They grow on trees. Not anymore. So, tweet at us and use like pound the Great Search, or at us at Adafruit, whatever ways. Let us know what you're looking for, and we're also out there helping people. And we see things, we help. We saw this one. You want to start with the tweet?
Yes. So we saw Tobias tweeted in response to Jerry, who had like a headachy gif about like how she is working on design and can't find a part. And Tobias says, "Welcome to the club. Anyone TPS 27081A for $15 a piece, usually 30 cents a piece." So they're talking about how brokers are, and I've seen this, like some brokers are what I would call ethical. It's like they'll charge a little bit more because it's rare, but they're not going to charge a ridiculous amount.
I like
We're
not
seeing
putting
10,
people,
20
yeah, I like not
prices.
putting people in, you can resist anything but temptation.
Yeah.
And so I think right now there's a lot of temptation for a lot of folks who do brokering or parts to charge whatever.
No, I have to actually redesign a couple of boards. It's not a big deal. I'm going to do it anyways. But it's like, okay, I'm not paying $15 for accelerometer.
Yeah.
I've seen it. I've had people quote me like $5, $6, $7, $8 for parts that I'm like, that's a 70-cent part. Like, I can understand like, hey, 50% more. Like I want to make a couple bucks, but I'm not going to pay it. Like if they find someone, great, but I'm not going to pay it.
Okay.
So
what is?
And I'm saying you shouldn't pay it either. Instead, you should tag us on social media and we'll find you an alternative.
We'll find an alternative, and that's one thing. Just because it's not the same part number that you're used to doesn't mean
correct.
It's
and
not something that you can
sometimes
replace.
The part number is similar, but sometimes it's not, as we'll see here. So this part is an I2C power switch, normally 35-week lead time, out of stock completely, and yeah, it used to be about 30 cents a piece. So let's look at the data sheet and so we can see what we're dealing with here, because I've never used this part. So this is a 1.2 to 8 volt, 3 amp PFET high side low switch with level shift and adjustable slew rate control. So basically you can use this. There's a VN coming in, and then there's a GPIO logic high and low. You can put in a slew rate capacitor here, a slew rate resistor here to how much you want to feed this this FET, and it will turn on. So it's basically like, it's like a PFET, but it's got a little bit extra in it just to make it special. Also, it's 1.2 to 8 volts and 3 amps. Now look, I may not be able to get you the exact same part, but maybe it's within the specifications you need. So let's use, and I want to highlight, there's a couple things. So there's new up here, right below, not in stock. You can sign up for stock notification where they email you, which is we did on Adafruit, so I hope they're inspired by. And also find similar parts, and they tell you how to use the similar parts tool, which I will tell you as well. So let's look. So what do we want? So we want an active part. I don't want to say general purpose because I actually don't know. We do want it with one output because we want it to be pin compatible. We want it to be 1-to-1 high side. I think I want the interface to be on off, but I'm not sure. Voltage, I'm not going to select because there might be a wider range or a range that's close enough, so I'm not going to be too specific. Same with the current. I'm not going to be too specific. I do want surface mount, and I do want it to be in SOT 23.6 or TSOT 23.6. So let's view similar. Okay, so another thing is down here, these are now, all your specifications that you picked are also available down here that you can like turn on or off specific ones, or you can delete the whole thing so you can see more clearly what you searched for. So we're going to be very picky. We only want ones in stock. Okay, there's only 13 similar-ish parts. The output type. So let's look at this chip again to see what is the output type. And it says it's a PFET. Okay, so let's go back here. P channel. Okay, now there's 8. Current output, looks like there's a couple options. Voltage load, I think other than the 5.5, so the 5.5, 2 to 5, that might be good enough, but I'm going to assume that they want, up to 8 volts. That's usually the high limit is what they want. So I'm going to turn those on. Let's look at more filters. Okay, so we have actually quite a few options, right? So this is really good stuff. And a lot of them are in stock. So let's look at, they're all on off. So it looks like we have a couple options, a couple different current options. So since we have a couple different current options, I'm going to start getting picky, and I'm going to say the other one with a 3 amp, I'm going to assume that this person needs something that's about 3 amps. So I'm going to pick only 2.8 and 3.3 amps. Okay, so here's the two that came up. One is almost the same, 1.8 to 8 volts. Another one is 1.5 to 12 volts. They both have an RDS on of about 40 milliohms. Checking this data sheet. Yeah, 40 milliohms or so. That sounds about right. And this one has slew rate control, although I'll say sometimes features aren't complete. It depends on the person who entered it in, if they they filled in everything. So I always take the features as a grain of salt. Always check the data sheet. And the pinout, the package is the same, which means I can now check if the pinout is the same. So these are both pretty cheap. So let's look at the V-shape part first. So the V-shape part. So here's what I always like to see. So the application circuit. See this? It's basically the same as this. It's very similar. There's the R1. There's the VN on off. R2, VN, R1 on off.
What's slew?
Slew is how fast you want the current to go in. It's a current limiting thing. If something is slewed, it means it's going to slowly ramp up. If you have high slew, it spikes up. There's times when you want it to react very fast. You want a lot of current. There's sometimes you want to reduce your inrush current because it could damage your components.
Use slew in a sentence like that.
What?
Use slew in a sentence like I want more slew because, or like,
Well,
too much slew.
last week we talked about op amps, and we actually wanted a high slew op amp because we want it to react to volume changes very
Gotcha.
quickly.
High slew.
High slew. Okay, so for this one, you see the same pinout. 2 and 3 are V out, 2 and 3 are V out, and 1 is the bottom of this. Looks like another MOSFET. So yeah, this one, and then there's a return. This shows the internal resistors, but this looks actually almost identical. I mean, I will tell them, you go and of course check that all the specifications match everything, but this is very, very promising. And there's 12,000 in stock, and then for this one. And notice that the part numbers are totally. Sometimes it's like, an NE 555 or TI 555 or an LM 555. They all have the same part number. They have different prefixes. These have completely different part numbers and prefixes, and that's not that's not unusual. Don't. It's nice when they are, but it doesn't necessarily mean it's bad if they're not. It just depends on.
Yeah, everybody, we're all going to have to adapt at least.
You
got to
be flexible.
Yeah, just because it's not
Okay.
the same part number doesn't mean you can't use it. In fact, that's going to stop a lot of other people from either getting the parts they need or maybe even some changes to their design. But
You gotta stretch.
yeah, you gotta do some flexing.
This one also RDS on. You see the specifications, and then you can see down here again the same thing. There's an input, 2 pins on the output. Pin 6 is, you can connect to a capacitor out here. 1 is. Listen, this one has 5. Yeah, 1 is from the bottom of this FET. 5 is to the on-off gate, and VN is on pin 4. So this is actually one of the times where I'm like, there's actually 2, looks like good options. Both have about 10,000 pieces of stock in Digi-key right now, and they're like 30 cents, 20 cents, even cheaper. So if you can't get that TI part.
Or if you're getting quoted like
$7,
$10 a part,
don't do it.
Don't.
Look, sometimes I agree. Sometimes there aren't any alternatives, but I'll say something. I've actually, other than very, very specific chips that are like, okay, yes, it's a one-off. Only this company makes this particular microcontroller in this package, and you need that exact microcontroller. No, then you might not be able to get that. But analog and linear components and power components. There's probably something out there. You're not out of luck. There's gold at the end of the rainbow. So that's the great search. So check it out. Send us your great crises, your bill of material crises, and we'll help fix them.
Where in the world is that part I need? The great search with Digi-key.
All right, and
Okay.
then just a little side note.
Yes.
Jim says, in telescope mount terminology, we refer to slew rate, which is how much angular motion per second it can move.
That's the same thing.
Yeah.
This is actually it's the same rotational motion per second, but the rotation is the it's numerically in the imaginary plane
Yeah.
or the voltage plane. Like it's rotating, but it's not physical. It's in a voltage or current mode.
Okay.
Okay, great.
That's our show for tonight. This is Jessica Ladyada.
Thanks, everybody.
All shows during the week. We have JP's product pick on Tuesday. 3D Hangouts on Wednesday. Show and Tell. Noah and Pedro are going to be hosting Show and Tell. We're going to be doing Ask an
Yay.
Engineer. And then Thursday, we've got JP's workshop, and Friday, Deep Dive with Scott. So full week ahead. Tons of things. And we'll be broadcasting Ask an Engineer from the Adafruit factory.
Soon.
Once again, very soon.
Soon.
The only reason we're not is because our shift overlaps with the team. Now, we're all vaccinated and we're past our 2 weeks, but we're still setting a good example. So when we do video broadcasts, we will take our masks off. So we want to make sure that everyone's out. So it's
Yeah.
just Ladyada and I. And we have ventilation and all this stuff. We just want to continue to set a good example. And then for the teams that are still around, if they're fully vaccinated and they're after their 2 weeks or 1 month, we'll start to work with them, and then over time, it'll be as normal or whatever normal is that we define together going forward. So we'll see everybody soon. There's shows during the week. Thanks for spending your Sunday with us.
Thanks,
we'll see
everybody.
everybody
Bye.
next week.